It's day 6 of Advent of Code 2025, and today we will be helping elves resolve their issues with Trash Compactor. So this Trash Compactor kind of provides us with a list of problems that are groups of numbers that need to be either multiplied or added, and it seems to be arranged vertically. So at the bottom we have the operation that we need to do, and then we kind of go line by line and either multiply or add those numbers as they are. So this is what happens, and we kind of get those results, and the grand total of every single operation taken together is what we are looking for. So pretty simple problem so far. We will try to solve it first. So I will take the inputs, set it here, and then we will do and read in the input. So we'll do lines equals read all lines, I think, and then I will do for each line in lines. So we will do. Okay, we can do all the lines actually, and we can do something like problems. It's gonna be a list of string, something like this. So we can do a line split, line split by white space, and we will do remove empty entries, and we will get parts of the line, and we get we add it to the problems list. Problems add parts. So we kind of read in every single line split by empty spaces so that we can get the proper view on the whole thing. And then what we can do is for int I problems problems 0 length, we can take the individual numbers and then use the operation that's at the end. So var numbers, so for each line, or actually we can do for line is problems length count -1, because we need to make sure the last line is, because that's operator. So we do numbers. Actually, we don't have to store them. We can just do operator multiply problems count -1, and we equals and I equals multiply. Then we do equals multiply. So we check if the problem, this is, oh right, it's a string. So if it's a multiply, and actually we can do split options, trim and trees, but it should be okay. So we check if it's a multiplication, then we do if starting number will be if it's a multiply, then 1, and otherwise 0, because in addition we start from 0, and then we do ulong parse line or problems line at index I, and the number we then either multiply or so ulong total 0 and ulong current equals 0, and then we do, or actually we can use the starting number, the current result, as like it. So we do current results, equals, or if it's a multiplication, then we do current result times equals number, and if it's else if it's addition, then we do current result plus equals number, and that should be it. So it's gonna be u long here, and finally, when we're done with this, then we do total plus equals current result, and that's it. So this way we should be able to calculate the grand total, which we return here as total to string, and we're done. So we'll see what happens if we run this against the test data. So the 6 numbers, the result should be, yeah, it seems okay. So let's see if we run it against the actual input. Pretty large number, but it is correct. So we have the first part solved. Let's go to the second one. So in the second part, the problem is a little bit different because it's written in right to left in columns. So each number is given its own column with the most significant digit at the top and the least significant digit at the bottom. So problems are still separated by empty columns. So each of the problems has a empty column that's separating it. And now what is the calculation going to look like? So if we have the sample input, that's exactly this. So if the sample input looks like this, what we are going to have is that rightmost problem is 4 plus 431 plus 623. So we kind of need to find the columns that are empty, and based on that separate the problems, and then use that separation to figure out the groups. So this is a little bit more complicated, definitely. So we'll need to find a way to properly separate those out. But it seems like to figure out where this separation lies, we can use the operator, because that one is always at the leftmost part of the number. So we can kind of find the range which we are working with this way. So what I will take this. We have probably not really able to use much of that code, but still. So what I will actually read in all lines and not parse things at all this time. And now we will probably go follow the line. So we'll take the last line. So operators line equals lines line count -1. So this is the line where the operators lie. And what we can do is to do for so we can operators index of any, and the first index will be 0. So first, so until, so we'll have first start index will be 0, and while our end index will be equal to index of any of after start index +1. So we need to find the next operator, and while end index is not equal to -1 until there is something that we can continue. Okay, let's see. We actually could do this do while. So start index is not equal to -1. So we can do something like this. So we can do this until we reach the start index of -1. At the end, we will do start index equals end index and continue this whole thing again. So we find the end index, and if end index equals -1, we will do, it will make it equal to operators line dot length. That's going to be, or length -1. So that's going to be, yeah, okay, length. So end is not inclusive. So the end will be excluded from the current operation. So now we have the range of indices where the current operation happens. And what we can do now is do for, and let's see, this is 8. So if there is a, okay, hopefully the line will always contain just the numbers, but if there is a break, I'm not sure what happens. So we'll see what happens when we go through this. But for, we will do for current column equals end index -1, current column greater than 0, and we'll go from the right, and we kind of take the numbers from the previous, from all the lines. So we build up the number, and it should be here 4 3 1 6 2 3 1 7 5 5 8 1 3 2 and so on. So it should be like this. So for current row lines dot count -1, because we exclude the last line, the line which contains the operators, and then we take like so take the current line, take the number, the character. No, it should be character. It should be lines current row and the current column. And if car is digit, then we kind of parse it. Number equals character -0. And we can take the current number that we have. So the current number equals, we start at 0, and we will take the current number, multiply by 10, times equal 10, and then we plus current number plus equals number. So we kind of expand the number line by line, and we get in the end the total that we can then run the operation on. So that means that we have ulong running total, no, grand total, it will be 0 at the beginning, and then we have ulong current total. We will initialize that based on the current operations. So the operators line start index equals multiply. All right, so you have something like multiply. If it's multiply, then we do multiply equals 0, and it's going to be ulong or 0 total. So we start with the current total, and then we do, and then we have the current number. And if we multiply, then we do current number, or current total times equals current number. And otherwise we do current total plus equals current number. And that should be it, hopefully, except for this should be a u-long because we need the big numbers. And the number should be also a u-long, just to make sure that we don't, it doesn't bother our compiler. So hopefully this will be a reasonable solution to the problem. So when we are done with this, and when we figure out the total, then we do current or grand total plus equals current total, and then we can just go forward. And finally, we return grand total to string. And let's see what happens. So we can maybe just to make sure that, well, we can try to turn it with this data, and we are already outside the bounds, which is not nice. So the start index here, how did we get start index that's higher than right. So start greater than, or actually we can do start index is not equal to operators line length. So basically what we had checked before is -1, but we are actually overwriting that with the length of the line, which made it overflow. And this is the total, which is a bit low, I think. So let's see what happens there. So in the first problem, we should have results something like here. So let's see if we run it with the test data, we should get the current total is 0 here. That's not supposed to be that. So in the first problem, we get first index and fourth index. That's fine. And we should be calculating something there. That's definitely not right what we're getting now. So what we should be going, okay, not to 0, but greater than equal to start index. That's the first problem. And then still it's not right. So multiply with current goal is -1. Let's see what happens if we debug this. So the current total is, so the current column is this. So we should be getting 3, 5, 6 here. So the number here should be 3, 5, 6. And we add it to this, and we should be getting the current total. And current total is 0 here. Why is it 0? What happened to our current total that made it 0? That is odd. So let's see. It became 0 for some reason. I'm maybe missing something very simple here. If it's, so current total is here. It's 1, so we should not be getting current total equal to 0. So, oh, okay. I see what's happening here. We kind of get here with an index of 4, start index of 1, but the current number is 0, what we're having here. That is weird. Why is that? Okay, so what happened there? Let's see. If I run this back here and do something like this, we should get the number. Oh, we're not getting any number. So actually, yeah, right. And the problem is that what we learned is that there is a single column that's completely empty that's separating the problems. That's what I'm missing here. So actually the end index should be -2 because that we are skipping also the empty column that is there. So that should be it, hopefully. With the test data now, if we run it, we should get 356. Yes, that's more like it. And the current total is 8544. Yes, let's see what happens if we run the whole thing. The result is this, and that is more like the number that we're expecting, even though there is a slight miscalculation somewhere. So what is happening? What is missing here? Let's see. I will put breakpoints here just to see what this data. So we have 356. Wait. That's not the one. Total here. Current total. I will put breakpoint here. So the total is 8544. That's right. But we are getting off somewhere. 625. That's still okay. What here? It's 325, 36. 3600, that's still fine. But then the last one must be off then. We are not getting the 4 there. Huh. That is interesting. So the 4 is lost for some reason. And why is it lost? So the last rows, it's going to be parsed. It's going to be totaled, but then we get 4, number 4 at the end. Of course, that's it. Of course. So the problem is that when we are at the end index, we are setting length to be equal to the length, but we should be actually setting length plus 1 because we are kind of simulating the empty column at the end as well. And that breaks our assumption here as well. So we need to check if it's greater or equal to length, for example, just to make the condition more solid. But like that was a problem because we are skipping the last number, and that meant the result was not right. Although now we're getting much less content. Let's see. If it's greater than operator line length. So what is the problem now? That is very odd. So we get 8544 and we end. Huh. If the index is great, that's odd. I'm probably missing something here. So the index is 4. Operations line is equal to 4 is greater than 15. Oh, right. I completely inverted the condition. So while it's greater or less than or equal to operator's line length, or no, actually is if it can be less than, that's fine. Okay, now we're okay. Was a slight misstep, but hopefully now we should be getting the right number. Yes, that's right. Okay, so let's see what happens if I do the test, the proper input file, and this huge number is correct. So yeah, we have solved day 6 after a few fumbles, but yeah, we're continuing successfully through the calendar. I will hopefully record the next two problems in a row as well, because I'm kind of behind the schedule, but still, thank you for joining me, and I will see you in the next one.